Okay, so guys, in this video we have to differentiate using the first principle method, and in this part we have tangent 3x. So we know that in the first principle method, first of all we have to make this equation a function. So how can I do that? First of all, y is equal to tan 3x, and then I have to do the increment in my dependent variable as well as the independent variable. So first of all, tangent 3x plus delta x, and also in the y. Now I'm going to move this y towards the opposite side of the equation. So delta y would be equal to tangent 3x plus delta x. And this y, while moving toward the opposite side of the equation, will have opposite signs. So over here it is positive and there would be negative y. Now I can simply put the value of y from the first equation. So it would be tangent 3x plus delta x minus tangent 3x. Okay, so which was the actual value of y. Okay, what we can do, we know that tangent is actually equal to sine over cos, right? So I can write the whole of this whole equation into the sine divided by cos form. So sine, now why am I doing this? Because in the previous questions we have solved for the sine case and also for the cos case. So those cases are much familiar to us, so we can use those identities in order to solve for the tangent question. Okay, now I'm going to take the LCM. As we can see that there are two fractions which are being subtracted, so I can take the LCM. We can see that cos 3x is actually not present over here, so I can write the numerator as 3 sine 3x plus delta x, this thing right over here, and this is going to be multiplied by cos 3x, right? Because this is not present over here. Then we have minus sine 3x, the same term present over here, then it would be multiplied by cos 3 x plus delta x, because this is the thing which is not present in the LCM of this fraction. That this is actually another identity, right? We have the identity sine alpha minus beta. What does this identity says? It says that sine alpha cos beta minus cos alpha sine beta. So I can see that 3x plus delta x, I can consider this term 3x plus delta x as my alpha and this 3x as my beta. So we can see that sine 3x plus delta x, which is sine alpha, multiplied by cos beta, then the negative sign cos alpha, which is cos 3x plus delta x, as my alpha was 3x plus delta x, multiplied by the sine beta, which was 3x. So this form is perfectly matching. I can write sine, what is my alpha? 3x plus delta x minus beta, which was 3x. That this term is actually present under a bracket, so I can use the brackets over here, and in the denominator we have cos. So I can multiply this 3 inside these terms. So I will have sine 3x plus 3 delta x minus 3x, and this entire term is under a bracket. Now these terms would be cancelled, and now I can move towards the fourth step of the first principle method, and that was dividing delta x on both sides. So I can simply divide delta x on both sides. Now I know that this term is actually getting complicated, so I can write it in this form. 1 divided by delta x would be multiplied by sine 3 delta x divided by cos 3x multiplied by cos 3x plus 3 delta x. Okay, so it is much simpler for me to deal with. This is actually the same term. You can see that delta x was being divided over here, and I can write it in this form, so it will again be equal to delta x would be divided by that. Okay, so in the previous questions we saw that we were having an identity like sine theta divided by theta, and it was having a limit of theta equal to 0, right? It would be equal to 1. Now over here I also want the same condition present over here, but the problem is we have a 3 over here. If I would just separate this sine delta x and delta x, it would again be sine delta x divided by delta x, which I can apply the limit and it would again be equal to 1. Okay, but the problem is over here we have 3, so I have to introduce a 3 over here so that it actually becomes sine 3 delta x divided by 3 delta x, so that I can apply the limit and then it would be equal to 1. So I want this condition over here, sine 3 delta x divided by 3 delta x. We do not have a 3 over here, so how I can introduce a 3? First of all, I will multiply this term by 3 and I will divide this term by 3. Same thing, right? Because the 3 would be cancelled and it would again be 1 divided by delta x. So we have 3 divided by 3 delta x. So we can see that sine 3x is present over here and 3x is present over here. Now I can apply the limit and this condition would be fulfilled. Okay, so at this point, I'm going to apply the limits so that I can move towards the fifth step. So we can see that sine 3 delta x and 3 delta x is present over here. So we know that limit of sine delta x divided by delta x, and where the delta x approaches to 0, we have this entire thing equal to 1, right? This is an identity. So how I can solve further? We have a 3 over here. Okay, so I can ignore this 3. It will be 3. It is a constant actually. So the 3 would be over here. Then we can apply the limits separately in all of these terms. So limit of delta x approaches to 0, sine 3 delta x divided by delta x, and over here again multiplied by the limit. I'm actually applying the limits separately in all of these terms because these are being multiplied, so the limits can be applied separately in all of these terms. Now you would argue that why are you not applying the limit on 3? Because 3 is already a constant, so the limit does not affect it. Over here we have 1 divided by cos 3x dot cos 3x plus 3 dot delta x. Okay, so I can simply put a 0 wherever I have a delta x in this term. So this will actually be equal to 1. This entire thing is 1, and I explained you how. This over here, wherever we are having a delta x, I can actually put a 0 over there. So over here we have delta x, right? So this would be 0. 3 multiplied 0 is again 0, so this term is cancelled. So what is remaining? We have 1 divided by cos 3x plus cos 3x. Okay, so this is the remaining thing. Actually it was being multiplied, sorry. What do we have now? It is time to write the final answer of this question. So what is remaining? We have 3 over here. Okay, so 3 in the numerator divided by cos 3x multiplied by cos 3x, which will be equal to cos square 3x. Okay, d by dx of tangent 3x, which is 3. This is actually cos, right? And if it is 1 divided by cos is actually equal to secant, right? So I can write secant squared 3x.